Hi students, let us take today's problems one by one. The first problem is this one. So assign the EZ configuration for the molecule. For this, we had to consider the atom attached on the doubly bonded carbon atom. Here, hydrogen and fluorine are bonded to this carbon atom. Then we want to give the priority on the basis of the atomic number. We know that the atomic number of fluorine is greater than that of hydrogen. We know the atomic number of fluorine is 9 and hydrogen is 1. So we give high priority for fluorine, that is priority 1 for fluorine and 2 for hydrogen. Next, this carbon atom. This carbon atom is bonded by chlorine and bromine. And compare the atomic number of bromine and chlorine. Bromine atomic number is 53 and chlorine atomic number is 17. So we can give priority 1 for bromine and 2 for chlorine. Then check the arrangement of the priority. Here the same priorities are arranged on the opposite sides, 2, 2 and 1, 1. So this configuration is E configuration. E means indigent. E configuration. This configuration is E. So then what is the Z configuration of this molecule? So by changing the position of the one of the atom, we will get a Z configuration of this molecule. By changing one of the atom, if by changing the position of fluorine from here and hydrogen is here, just changing the position of the one of the atom, we'll get the opposite configuration of the first molecule. So bromine and chlorine. Okay, let's change the position of fluorine and hydrogen from here to here. Then this configuration would be Z configuration, because this is bromine, here bromine, here chlorine. So 1, 2, here 1, 2. Here the same priorities are arranged on the same side of the double bonded carbon atom. So the configuration is Z. Okay. This is the second example. In this case, the carbon is directly connected with this carbon and hydrogen. While comparing the atomic number of the carbon and hydrogen, we know that atomic number of carbon is 6 and hydrogen is 1. So give high priorities for this one, 1, and priority 2 for this. And then compare the atomic number of bromine and oxygen. That means carbon is directly bonded with the oxygen, not hydrogen. So the atomic number of oxygen is 8 and bromine is 35. So atomic number of bromine is greater than that of oxygen. So we give priority 1 for bromine and 2 for oxygen. And then compare the priority arrangement. Here the same priorities are arranged on the same side of the double bonded carbon atom. So this configuration is Z. So next we can draw the E configuration of the molecule by changing the position of the atom. By changing the hydrogen, the position is from here to here. Hydrogen here and CH3 is here. By simply changing the position of this atom, this is bromine and here is hydroxyl group. Now by changing the position of the one of the side of the atoms, we will get the opposite configuration. So this configuration is 2, 1. This configuration become the same priorities are arranged in the opposite manner. So this configuration is E configuration. Next one, the third example is this one. Here In this case, carbon directly bonded with nitrogen and hydrogen. Atomic number of nitrogen is 7 and hydrogen is 1. By comparing the atomic number, we give priority 1 for nitrogen and 2 for hydrogen. And here the carbon is bonded with the bromine and oxygen. We already seen that atomic number of bromine is greater than that of oxygen. So give priority 1 for bromine and 2 for oxygen. Here the same priority 2, 2 and 1, 1 are arranged on the same side of the double bonded carbon atom. So this configuration is Z configuration. Then its opposite configuration is by changing this opposite configuration will get by changing the position on the one side of the group. We change the position of the NH2 from here to here. So here we can place hydrogen atom and this side we can place NH2 atom. Okay, NH2. Okay, this is hydrogen. Hydrogen and here bromine and hydroxyl group. Bromine and hydroxyl group. Priority is later. 1, 2, here 1, 2. Here the same priorities are arranged in on the opposite manner. So this configuration is E. Okay. Next one. Assign E or Z designation for the modeling. E or Z configuration. In this case, here the carbon is bonded with oxygen and carbon. We know the atomic number of oxygen is greater than that of carbon. So we can give priority 1 for oxygen and 2 for carbon. In this side, the carbon is bonded with the methyl group and chlorine. So carbon is directly bonded with the carbon, not hydrogen. Carbon is directly bonded with the carbon and chlorine. Atomic number of chlorine is greater than that of carbon. So we will give priority 1 for chlorine and 2 for carbon. Then here the similar priorities are arranged on the opposite sides, 1, 1 and 2, 2. So this configuration is E configuration, E configuration. In the second example, the carbon is directly bonded with fluorine and chlorine. So comparing the atomic number of chlorine and fluorine, we give priority 1 for chlorine and 2 for fluorine. We know the atomic number of chlorine is greater than that of fluorine. In this case, here carbon is bonded with carbon and carbon. Both the atoms are same, so we had to consider the next atom. Here the carbon next is connected with the hydrogen, 3 hydrogen atom. This carbon is connected with 3 hydrogen atom because CH3. Whereas this carbon is connected with the 2 hydrogen and 1 CH3. 1 CH3. This is the case of the lower carbon atom. So in this case, both the atoms are same. So we had to consider the next atom. Here the next atom is hydrogen. Here also next atom is hydrogen. Next, then consider the next atom. Here the second one is hydrogen. Here also second one is hydrogen. Next, consider the third one. Here the third one is hydrogen, but here the third one is carbon. So we can give priority 1 for this group and 2 for this side. So in this case, the same priorities are arranged on the same side of the double bond. So this configuration is Z. Okay. Yes, students, please check your answer.